Welcome back, mathematicians. In this video, we are going to derive the quadratic formula from the general form of a quadratic equation, which is ax squared plus bx plus c is equal to 0. We will do this using the completing the squares method. So anyone who really doesn't like the completing the squares method as a way to solve quadratic equations, we need to put some respect on that method because without it, we would not have the quadratic formula. So to do this, we'll start by moving the constant c to the right side of the equation. As a result, what we have is ax squared plus bx is equal to negative c. Next, our goal is to factor a. So when we factor the value of a from the two terms on the left side, we have x squared plus b over a times x as our other factor, still equal to negative c. Our goal now is to add a constant into those parentheses to create what is called a perfect square trinomial. So we have a times x squared plus b over a times x plus, and we need a constant there, a value that will create a perfect square trinomial, equal to negative c. And we're going to have to add a value to the right side as well in order for us to keep the equation balanced. So how do we get that value? Well, we're going to take the linear term, the coefficient to the linear term that is, so that would be b over a. We're going to divide it by 2, and we're going to square it. Now, when we take b over a divided by 2, we get b over 2a, quantity squared. And when we square it, we get b squared over 4a squared. So that is the value, the constant, we're going to add to the expression inside the parentheses. So that'll be b squared over 4a squared. Now the value that we're going to add to the right side is not actually specifically that. So we always need to ask ourselves, well, what is that value really on the left side after we would hypothetically distribute a? So in other words, what we need to do is multiply the value of a, the leading coefficient that is outside the parentheses, times the b squared over 4a squared. And what we get is b squared over 4a. And so that is what we will add to the right side. So again, if we were to reverse this process, distribute a, combine like terms, move c to the other side, we should be able to go back to the original equation, which we could by adding b squared over 4a to the right side, but we couldn't if we added b squared over 4a squared. Our goal now is to factor the left side. So when we factor, we end up getting a times the factor x plus b over 2a times x plus b over 2a. Now the quick version is that we can find this value by looking at the work we did earlier. This expression, after we divided by 2, after we simplified that ratio, but before we square it, will be the constant in our binomials. Now on the right side, I would like to combine like terms to get one fraction. To do that, I'm going to have to find a common denominator. The common denominator will be 4a, so I'll have negative c times 4a all over 4a plus b squared over 4a. Next up, I will combine that to one fraction. Now I'm going to rewrite the left side, so I have a times x plus b over 2a quantity squared. Because those two binomials were identical, I can write them as one binomial squared. On the right side, I'm going to combine this to one fraction and do some rewriting so that it looks a little nicer. So I'm going to put the b squared first minus 4ac. So I just reordered the c, the 4, and the a, which you can do based on the commutative property of multiplication. And it's all over 4a. Next, I'm going to have to move the a to the right side. Now, most people would say to divide. I'm going to choose to represent this as multiplication. So I'm going to multiply by 1 over a to both sides. And when I do that to both sides, on the left side, the 1 over a times a undoes each other. So all I'm left with now is x plus b over 2a, quantity squared. On the right side, I'm going to multiply across. I have two fractions. You multiply the numerator together and the denominators together. In the numerator, I have b squared minus 4ac. In the denominator, I have 4a squared. Okay, I'm very close to the end. Next, I'm going to take the square root of both sides. That will undo the square on the left-hand side. And on the left, that will leave me with x plus b over 2a. Now on the right, anytime I'm square rooting both sides to solve an equation for x, I'm going to include a plus or minus on the side that is opposite the power that you're trying to undo. So opposite the x plus b over 2a, because that had the power of 2 that I was trying to get rid of. So I have plus or minus, and now I've got the square root of b squared minus 4ac all over 4a squared. Okay, I need to clean that up a little bit. I'm not happy with the way that looks. So to do that, I'm going to start by breaking up the radical. So I have x plus b over 2a is equal to plus or minus all the square root of b squared minus 4ac in the numerator. Now there's nothing I can do with that to simplify it. That's going to remain as is. But I can simplify the square root of 4a squared, because the square root of 4 is equal to 2, and the square root of a squared is just a. So now I have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 2a. Finally, I'm going to subtract b over 2a to both sides, and so this gives me my final result, which is going to be negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. But what we notice is that we have a common denominator with both fractions, so we tend to write this as one singular fraction, giving us the final result that everyone is familiar with, which is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that is how you derive the quadratic formula from the completing the squares method. All right, guys, good luck.